Hello everyone, welcome to my channel Strong Math. Today in this video I will explain about the new topic which is known as integration. At first we will discuss about indefinite integral. So watch the video very carefully, don't skip the video. What is integration? Integration is the reverse process of derivative. You may often say that integration is called antiderivatives. Integration is denoted as a special symbol. This snake-like symbol is the symbol of integration. Integration of any function fx dx is equals to, suppose, another function fx and plus c, some integrating constant, some constant which is known as integrating constant. Here the function fx is known as the integrand. This is the symbol of integration. This is the variable of integration. With respect to this variable we do the integration. So we must write a differential of the given variable. Okay. Then if we get another function after integrating this function, if we get another function f of x, then we must write a constant which is known as integrating constant in the case of indefinite integral. Okay. For definite integrals we don't use the integrating constant. The structure of definite integral is there must be two limits, upper limit and lower limits, and for indefinite integral we don't use those limits. Okay, suppose this is indefinite integral, and suppose for definite integral we write integration a to b fx dx. Okay, in this case if we get the result as capital Fx, then we have to take the values of lower limit as well as upper limit. So we have to write the form of this kind of integration as fx lower limit a upper limit b, and after that we have to put the values. Then we write f of b minus f of a, value of the upper limit minus value of the lower limit of the resulting function. So this is definite integral. At first we will explain different kinds of indefinite integral, and after that we will explain the definite integral. Okay, so this is the common difference between indefinite integral and definite integral, that in indefinite integral we will, after integrating the function, we will get another function and we must write the integrating constant. For definite integral no need to write the integrating constant because there exist definite values of the function. That's why it is called definite integral. We must integrate the function in a certain bounded region, and the bounded region is bounded by a lower bound and upper bound is b. So in this region we have to integrate a function for definite integral. In the definite integral no need to write the integrating constant. In the indefinite integral we have to write a constant which is integrating constant, and no need to write any lower limit and upper limit. As I said earlier that integration is the reverse process of differentiation. So if we differentiate any integration of any function, then we will get the function itself, because differentiation is the reverse process of integration as well as integration is the reverse process of derivative. So if we take derivative of integration of any function, then we will get the function itself. Similarly, if we integrate any derivative of any other function, then we will get the function itself. Suppose integration ddx of gx dx, then we will get gx itself. Okay, so this is the basic concept. Now look at the screen. There are some given formulas. Now let's explain some formulas related to derivative as well as integration. Suppose derivative of x to the power n, we know that this is n x to the power n minus 1. The power will come at first and then we have to write x to the power n minus 1. power will be decreased. Similarly, if we integrate x to the power n with respect to x, then this will give us x to the power n plus 1 by n plus 1 plus c. This is the difference between integration and differentiation. Suppose derivative of x is equals to 1. If we integrate x, then if we integrate 1, then what we will get? We will get x plus c. Look, derivative of x is 1, but integration of 1 is x. Okay. Now derivative of e to the power x. Derivative of e to the power x is e to the power x itself. Integration of e to the power x is e to the power x itself. We must write the integrating constant in each case. Okay. Derivative of log x. Derivative of log x gives us 1 by x. Similarly, if we integrate 1 by x, then we will get the log x. Log x plus c. Look, derivative of log x is 1 by x, and if we integrate 1 by x, we will get log x. Log mod x. Okay. Now derivative of a to the power x is equals to a to the power x log a, and integration of a to the power x dx is equals to a to the power x by log a plus integrating constant c. Now you have to remember one thing, for the coefficients, if we do the derivative of any function with coefficients, then that coefficient will comes out and stay in front of the function, and for integration that coefficient will be under the function. That is, for example, we know that integration of e to the power x dx is equals to e to the power x plus c, as well as derivative of e to the power x is equals to e to the power x. But in case of, if there is any kind of coefficient, suppose integration e to the power mx dx, then this will be e to the power mx by m, the coefficient will be under the function, plus c. And for derivative, suppose we take the derivative of e to the power mx, then this m will be in front of the function, and this will be m e to the power mx. This is another basic difference between the derivative and the integration. In integration, coefficient will be under the function, and in derivative the coefficient will be in front of the function. Okay. Now let's move on to the algebra of integration. Number 1, integration of fx plus gx, addition of two functions. Integration of addition of two functions gives us integration fx dx plus integration gx dx. Similarly, if we take the difference of two functions, then integration fx minus gx dx, this equals to integration fx dx minus integration gx dx. Okay. Third one, if any scalar k, scalar or constant k is multiplied with a function fx, then the integration of this function will be k into integration fx dx plus c. For multiplication, there is a special rule which is known as by parts rule. We will explain by parts rule in some other videos. That is another section of integration, and for division there is no rule for integration. Let's solve some problems, simple problems related to the formulas which we have already discussed in this video. The first problem is integration ax square plus bx plus c dx. So look, we can separate them by the algebra of integration. So ax square plus integration bx dx plus integration c dx. So if now look, a, b, c are the scalars, so we can write integration a integration x square dx plus b integration x dx plus c integration dx. Let's rub this one, we will explain this problem later. Now look, a integration x square is equals to x to the power 2 plus 1 by 2 plus 1, by which law? By this law, integration x to the power n dx is equals to x to the power n plus 1 by n plus 1, right? Okay. So we know that for every integral we must take an integrating constant. So you can write plus c1 plus b integration x, that means power of x is 1 here, so this will be 1 plus 1 by 1 plus 1 plus another constant c2. Here c is the scalar, integration dx is x plus another constant c3. Instead of writing integrating constant each and every time, we may write a single constant. Okay, this equals to a by 3 x cube plus b by 2 x square plus cx. Now look, c1 plus c2 plus c3. Together we can take another constant because c1, c2, c3 are all constants. Instead of them we can write another constant d. So after calculating all the integration, we may write a single constant. No need to write, it is not necessary to write integrating constant in every cases, in every integrals. Instead of them we can write a single constant. So this is the process of finding the integration of this function. You have to remember all the formula related to integration as well as differentiation. Let's move on to another problem. Suppose we have a problem related to trigonometric functions such as integration sec x into sec x plus tan x. Now look at the table, formula table. At first multiply sec x, then this will be sec square x plus sec x tan x, right, dx. Now we can separate them. This will be integration sec square x dx plus integration sec x tan x dx. Now look at the table, formula table. Integration sec square x dx gives us tan x, no need to write any integrating constant, plus sec x tan x, integration sec x tan x is sec x. Now we can write a integrating constant because in each cases if we write two integrating constant, then their sum gives us another constant. Okay, so this is the answer of the integration of this given function. Okay, now what to do? You have to memorize each and every formula, then you can easily find out the integration of the given function. Suppose let's move on to another problem, integration e to the power 3x minus 2 dx. At first let's separate them, then this will be integration e to the power 3x dx minus integration 2 dx. So this equals to, look, e to the power x, integration of e to the power x gives us e to the power x, so this will be e to the power 3x, but there is a coefficient present here, so the coefficient will be under the function, minus 2 into integration dx. This equals to 1 by 3 e to the power 3x minus 2 integration of dx is x plus c. Now you have to remember why integration dx is always x plus c. Why? Look, if we integrate dx, then there is 1 is present. We are integrating 1. 1 means we can write x to the power 0 dx. Now apply the first rule, then this will be integration x to the power 0 gives us x to the power 0 plus 1 by 0 plus 1 plus c. This is equals to x plus c. That's why integration dx is x plus c for all the time. So you have to memorize all the formula for your calculation of integration. So this was the first part of integration, that is indefinite integration. That is the basic concept on indefinite integration.
Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.